Microevolution is the adaptation of organisms that we see and we can observe it. It's the ability that organisms have to rapidly adjust to differences in their environment at a genetic level. It's very important to emphasize it's at a genetic level. So we're not talking about physiological adaptations. Those obviously have to be there already. But if you have a population of organisms, they will have genetic variability in them. And when there is a change in the conditions, you'll find that that population will be able to produce individuals who do well in that changed environment. If they can't do that, then the organism will go extinct, at least locally, where that change has occurred. So you can think of it as a way in which organisms survive, but they do not produce new genetic information necessarily. They're taking genetic information that already exists and they are using that. They're recombining it in ways that allow them to survive in a new set of circumstances. It may also be, in some circumstances, that you see mutations that actually break genes that allow organisms to survive better for one reason or another. One of the ways in which bacteria, for example, get the ability to withstand antibiotics, they become antibiotic resistant. One way in which they do that is by breaking genes that are necessary for the antibiotic to work. I'll give you an example. For example, in penicillin-resistant bacteria, one way in which the penicillin resistance develops is by losing control of the normal system that those bacteria have to withstand small amounts of penicillin. They have a system that apparently allows them to pump it out of their cells. But there's just a little bit there because normally they don't live in an environment with large amounts of penicillin in it. But if you take penicillin to try to kill the bacteria, if there's one in there that system is broken so that they're already producing massive amounts of this one system that pumps penicillin out, hey, they can survive. So the system is broken, but it allows them to survive under those very special circumstances. Those kinds of organisms, you can think of them as being a little bit like a race car. You know, if you look at a race car, it's not a good car for driving every day. It's actually a terrible car, but everything is designed so that it can go very fast around a track. So there isn't an air conditioner, for example. So you could just break off the air conditioner and you can make your car go faster. They may not have headlights. Why would they carry around headlights when it's daylight? They don't need headlights. They can go faster without carrying all of that extra stuff around. But you're breaking the car. You're making the car worse to make it faster under one set of circumstances. And you see that commonly in bacteria. There are other kinds of methods that are also used to develop antibiotic resistance. But what you typically don't see is the production of new genetic information. Information comes from a mind. It doesn't come from, randomly putting letters together or something. And that's as true for DNA as it is for writing a book or anything else like that.
Nice. For the other hand, we have macroevolution.
Yeah.
So how does it work?
Macroevolution is the idea that if you keep doing microevolution, you can somehow or other get new kinds of creatures. And it's very important to define the terms that you're using when you talk about these things, because otherwise it becomes quite confusing. So macroevolution is the idea that you can go from an organism that's maybe the size of a rabbit with fur and all sorts of things, and it can, over time and subjected to natural selection, somehow or other turn into an elephant, or maybe turn into a blue whale, or maybe you could take algae and have it turn into a coconut tree. That's the basic idea of macroevolution. So when you're doing macroevolution, you are coming up with new, novel features that organism has. With the elephant, it would be a trunk, and with the whale, it would be having its, moving its nose to the top of its head and having fins instead of legs. All sorts of serious modifications to the body of that organism. Not just small adaptations, big, profound changes in the architecture of the organism is what we're talking about, macroevolution. So micro basically means small changes to allow an organism to survive and thrive in a changing environment. It's like they're pre-adapted in a way to different challenges that organisms face. But macroevolution is the creation of a whole new kind of thing. We're not necessarily talking about what we might call a species. And that's an important thing to keep in mind. Definitions of species are all over the place. So yes, we might get different organisms or different populations of organisms that drift apart for various reasons that came from a common ancestor, but they remain fundamentally the same. For example, here in the Galápagos Islands, there is a newly identified kind of iguana, and it's quite pink. Well, it hasn't developed a brand new pink pigment. That might be possible, who knows? But the pink that you're seeing is actually the blood through the skin. So it's actually the loss of pigment that makes it a pink iguana, which is interesting. And they're distinctly different from others that produce either a yellowish pigment or the quite dark grayish pigment.